Hello together, welcome. I'm really happy that I can see all of you in this meetup. Today, our colleague Tomasz Bagiński will introduce great subject, automated versioning of software. From organization point of view, please, if you have any questions during the presentation, you can type on the chat so we can collect them, or simply we'll wait for your questions after the presentation. After the presentation, we can turn on also microphones, so we can also hear your question while the presentation will be conducted. All persons will be muted. Tomasz, could you start your part, which is the most important one?
Okay, thank you. Thank you, Gabriel, for introduction. My name is Tomek, and I'm backend developer at VM.PL. I specialize in Microsoft technologies and .NET platform. My main programming language is C#, and I have been working with this platform for over 5 years already. Today, I would like to bring up a problem of software versioning and suggest you a tool that allows to get rid of manual steps and possibly improve your approach to software versioning. And although I am a .NET developer, this is a technology agnostic presentation. So you should be able to benefit regardless the technology you are preferring. This presentation will have following structure. First, let's talk why software versioning is important for us as developers and for the end users of our software. Then we will review how to version software with semantic versioning and possible implementations that I have seen in different projects. Finally, I will introduce the GitVersion tool and present the basic configuration. I prepared exemplary cases where I used GitVersion in 2 different configurations. Let's start by asking a question. Why do we care about versioning of software? So first and foremost, we want the version number to be meaningful to the end user. If we are delivering a dependency package, for example, and version it properly, the version number will tell the user what changes to expect. Just bug fixes, new features, or breaking changes. We as developers can also benefit from proper versioning scheme. For example, being able to track the versions installed on our environments. So if any problem occurs during development, it will be easier to identify the cause. Finally, the right versioning scheme will help us to record the release history in the repository. So it might come in handy in case of future hotfixes. Now we can ask another question. How to do versioning properly? We should not look too far or reinvent the wheel. Semantic versioning is a standard that is well documented and can be used straight away. It defines very nicely how you should make use of the well-known major-minor patch scheme. Semantic versioning also defines how you should add pre-release labels and build metadata to your version number. The rules are that you increment the major number when you make changes breaking the API, the minor number when you add functionality which is backwards compatible, and the patch number when you make backwards compatible bug fixes. The pre-release can carry some more meaningful information about the version, like release candidate, hotfix, or feature name. You can also add metadata to the version number, and usually it is a very good idea to include commit hash in the version, so it is easy to identify the commit that was used to build the version. Those simple rules will hugely improve readability of changes in your version number. Let's have a look how we can implement the versioning in our build pipelines. In general, we can split the implementations into two groups, manual and automated. In the manual approach, you can pass the version as parameter to the build pipeline, or even have the version number hard-coded in some file in your repository and update it when needed. This approach has one huge disadvantage. You have to remember to update the version and deduct the version number by yourself. But assuming you host your code in a Git repository, it's a perfect candidate for automation. If you create tags after each release, which is a good practice, you can implement a script that will traverse the Git tree and calculate the version for you. But again, we should never reinvent the wheel. And this is where GitVersion comes into play. GitVersion is a flexible tool that does the version calculation based on Git tree for you. It bases on a convention of tags and branches. Can be configured in 3 different basic modes, plus the configuration is almost unlimited. So you can create your own configuration of your choice. The calculated version is fully compliant with semantic version, which I mentioned at the beginning of the presentation. This tool is also cross-platform, so it works on Linux, Windows, Mac OS, whatever you want. It can be installed as a .NET tool, but recently .NET is a cross-platform thing, right? So there is nothing stops you from using it on all the platforms. And regarding the installation, I will redirect you to the documentation page because there are several options depending on your setup. And this is how to basically use the GitVersion. So it is as simple as calling a command line interface, which will return a JSON object that contains lots of useful information about the version. You can also call it with additional parameter, like I did here, the show variable. So you can limit, or you can just pick which concrete version do you want to use. And to be honest, this is the most flexible approach that I can imagine, and it can be easily adopted in any build pipeline. You can easily pass the obtained version to the build step. In C#, it would be passing it to the .NET build command, right? But I understand that in different technologies, there is basically a similar process. So we can provide the version number to the build step. Let's have a look at the configuration of the tool. So the 3 modes that I mentioned before are continuous delivery, continuous deployment, and mainline. Let's say some of big buzzwords here, but since those are only 3, the best way is just to experiment with all of them and then pick the one that we prefer, the one that sticks to our needs the best. But there is also a helper that can basically point you in a good direction, and this is built in wizard that asks you several questions and tries to pick the proper configuration for you. So if you write GitVersion init to the command line and pick 2, it will ask you about the branching strategy you are using in the project, and then it will try to describe you what to expect from which configuration. But as I said, we have only 3 default configurations, so let's have a look, right? I will I prepared examples for two of them that I find most useful. And let's see them in action. So this is the mainline mode. And what you're looking at is the Git tree of my sample repository. In this example, I tried to imitate a case with master branch and feature branches, similar to GitHub flow approach. So let's go commit by commit and see how the version calculated by the tool changes. So we start on the master branch and create some initial commit. This commit is tagged with the 1.0. And here you can see the version calculated by the utility. So the tool understands, okay, you added the 1.0 tag. So probably this is the stable version 1.0, right? This is how the tagging repository after releases work. After the 1.0, we create a feature branch and call it feature blue. So the tool immediately, it does some assumptions. So you created a branch, a feature branch. So you are probably working on the next version. So let's change the version number. And so it's automatically updated the patch version and added the name of the feature as a metadata, as the pre-release label, right? Together with the number of commits that were added since we created the feature branch. So we have 1, 2, and 3. Once we merge it back to master, and pay attention that this is a squash merge. I didn't add those 3 commits to the master branch, but rather created just one merge commit to have one commit with the feature blue on the master branch. And it's generated version 1.0.1. So again, stable version and increased patch number. Same happens after I worked on the feature green and the feature red. So after merging those 3 features, our patch number changed to 3. And to be honest, this is my favorite configuration of GitVersion because this is so simple. Basically, each commit to the master branch increases the patch number. If you want to increase the minor number, you would create a tag. For example, tag this particular commit 1.1, 1.0, and starting from here, the patch number would be again 0, and everything is clear, right? It's very simple, and in my case, and it works very nicely for the dependency packages because I don't want to I don't want to use sophisticated branching strategy, just simple mainline. And this is how it works, right? Let's now have a look at the bit more complicated example using the continuous deployment mode. So the biggest difference here is that we have develop branch that we use to merge our features before they go to master. And the merge to master happens only at the time of releasing to, let's call it production, right? And we also, at the time of the release, we make a tag on the master branch to indicate the point in the history when we created the release build. So let's start again from the beginning of the Git tree. So we have the initial commit tagged, and the version is 1.0. Then the feature blue, which behaves similar than we had in the mainline mode. The difference is that GitVersion upgrades minor instead of patch, but this is just the default configuration. You can do whatever you want, right? With this, there is this YAML file that you can add different ideas and configure the tool to your needs. So the default is that it increases the minor. And after we do a regular merge to develop branch, we get this number. So 1.1 alpha.3. And .3 is the number of commits since the last stable version. And we have all of those added to develop because we did the regular merge, not squash merge. Then we start to work on the feature green, do 2 commits. This is not a surprise for us, right? We have 4 and 5 consecutive numbers. They come from the difference from the stable version. Merge the feature to develop, and then merge the feature to master. And on master, we tag it with 1.1. And since now, we informed the tool that since now we are stable 1.1. And after we start to work on the new features, the tool immediately know, okay, now you started to work on 1.2. And the history repeats, right? So not much more complicated than the main line, but a bit more stuff, right? We have the keyword here, alpha, for the builds that were done on develop. And this is one of the conventions that are in GitVersion, but I don't want to go too deep into the details here. Just wanted to show you the scenario, how to use this tool. If you're interested, you can ask me some question or maybe refer to the documentation page. So I would like to show you the 2 documentation pages that are worth to visit. One is GitVersion and documentation of the tool, the installation steps, and the second is semantic versioning documentation. Small page, but very useful. Very, let's say, very technical. But once you get the idea behind semantic versioning, it's very nice to use. So thanks, that's all from my side at this point. And feel free to ask any questions.
Hello, I actually have a question.
Okay.
So I actually didn't work with Git at all. I'm actually working on Perforce. And the way how we use versioning is not actually like a major, minor, and patch version. We actually just use the changeless number. So is there an advantage of having the versioning set in that way instead of just having like a changeless number, and you know that this is all the things included in for this version of the product you are developing?
So the first thing that comes to my mind is that there are automatic ways to manage your dependencies. The dependencies. For example, in GitHub, now there is Dependabot, right? And if you follow the semantic versioning, the tool will be, the Dependabot will be aware that I should not merge this, I should not upgrade and merge this, this new version because it may contain the API breaking changes, right? So it will not have to, go through your changelog, but looking just at the version number. So it sees that, okay, the major increased. I should not merge it, right? Or, I mean, this gives you maintaining this semantic version gives you a bit more opportunity in terms of automation of dependency management, because if you stick just to the changelog, you have all in text, right? I understand that probably you should do both, right? Like having the semantic versioning plus the changelog, but again, it depends on the use case.
Yeah. I mean, it does make sense. Like in our case, we actually have a person hired to basically look at certain features, certain new changes, if they can be merged or not. So yeah, it does make sense for automatic versioning and understanding all the risks.
Okay, thank you for your question.
And hi guys, thanks for the nice presentation. I actually have one question: how the tool will handle parallel branches?
So maybe let's come back to the. Yeah, that's a good point actually, because my examples were quite simple, right? So in this case, if you create in parallel, let's say a feature yellow, right? So it would be 1.0.1 yellow. And that's the difference. So if for example, I work on the feature blue and deploy it to, let's say, environment 1, you work on feature yellow and deploy it to environment 2, then you can verify, okay, on 1, we have the version blue, on 2, we have version yellow, right? So this is the benefit you get. So you don't just look at the numbers, but there is some information that which is which, right? And that's why this pre-release label is so useful, because it tells you the name of the feature, right, that you are working on. And once I merge, basically whoever merges first will increase this number, this patch number in the mainline mode, right? And it's similar in the continuous deployment. So it works pretty nicely, to be honest. We are using that in, let's say, medium-sized team for developers, and no issues, basically, right?
Thanks for the explanation.
Okay,
and
thank you.
In case I would like to bump the major version, what should I do?
You should create a tag. So the most important source of information for GitVersion are tags. So if you, for some reason, want to switch from 1.0 to 2.0 after this merge, you just create the tag 2.0, and starting from here, you're on 2.0. As simple as that. There are some techniques in the tool that I don't really like. That you, for example, contain the word major, minor, patch in the commit message, and the tool understands it, but it's very hard to read. It's sometimes just surprising that the version updated and why, right? We have no tags. So the best approach is just stick to tags, and everything will be clear, right? Just remember to protect the tags in the repository, because if someone will start to play with them, delete, then probably some surprises may happen. But if you are just sticking to tags, you're on the safe side.
Yeah, cool. Thanks for the answer.
Thank you.
And I'm just looking at the continuous integration page on your website. Do you plan to have some integration with Bamboo or TeamCity?
So maybe I was understood wrong. I'm not connected anyhow with the creators of the tool.
Okay.
I'm just the user. I just wanted to show off that, hey, people just take it, use it, because it's very useful and it works. So I have no idea what are the plans. I know that the version is already 3, so several years of development, and the tool is quite mature. There are some integration with Azure DevOps, with GitHub Actions, but I don't know about any others. Just the command line can be used anywhere in any environment, and that's basically the advantage, right?
Cool. So I can see it's an open source project, so probably somebody can create or prepare a contribution and provide the support. So yes,
yeah.
Thanks for the answer.
Okay, thank you.
If there are no further questions, then we can say thank you, Tomek, for the great presentation. we encourage to take a look at the document and to use it, yes?
Yeah, thank you. I encourage you all to have a look and benefit if you can. Thank you for participating, and thank you for your time, and have a good afternoon, everyone.